Hey guys, Miss Cochran here, and we're on page 16. I'd like to pick up and review what we talked about yesterday and work number 2 together. Problem number 2, the first thing that you might notice, and even without graphing, that it's even, and it is a positive even function, which means it's going to end, our ending behavior should be up, up. Our ending behaviors should be up, up. So up, up is positive infinity and positive infinity. So you could write that in. That is just looking at this first term and seeing the power of 4 and that it's positive. Now, moving on, the next thing that I would have us do is go to our graphing calculator in your y equals and type in the problem. So I'm going to quickly type in having some technical difficulties. Okay, there we go. Now, make sure that you have all of your symbols, that your signs are there, that your letters are all where they're supposed to be. Once you're satisfied that it is correctly entered in your calculator, then press graph. It does confirm that it's an up, up on our ending behavior. It has 3 turns. There's 1 here, 2, and 3. So it does follow that pattern of the degree 1 less of turns. So 4 minus 1 would make it have 3 turns that are possible. The next thing that I might notice is that the maximum looks to be at 0, 5. Before I do the maximum, let's go ahead and discuss the range and domain a little bit. Domain are all the x's, and in this graph, as it goes up, it does get wider. It's not doing it very quickly, but it does move out. So it is using all of your x values. So all real numbers are possible for your x's. The range would be your y's, and the graph does not go down here. It starts off at this location, which is a little under the -3, it appears. So from that point, and it moves up. So I can't really see what that number is until we compute it, but it does go all the way up, which I know is positive infinity. I know it's something -3, because it doesn't look like it goes all the way to -4. In order for us to find that location, I would have to compute it. I'm going to go to the second trace, and I'm going to find that minimum. Okay, so I'm calculating the minimum. I have to get left, when it says left bound, of the location I'm trying to find, which is this one down here. I'm left, so press enter once. Move your little blinky man to the right of that location, hit enter once. To bypass the guess, hit enter, and then we can see our answer. This is one of our minimum answers, so I'm going to also write it right here. It is a -1.84 and a -3.31 for the y value. Now, and I did just round it to the to 2 decimal places. Now, we mentioned range, and now that we know that y value right here, the lowest point on the graph for y is at this -3.31. So that's where our range stops, -3.31, and it goes all the way up to infinity. So now I have domain and I filled in range. Now we can go and find the other items. Now, I'm going to do the increase and decrease intervals after I find all my maximum and minimums, because those are the points at which the increase and decrease intervals are defined. Now, I'm going to do the process again, so I'm going to press second trace, and this time I'll find the max. Now, when I choose maximum, remember my max is up here. on our graph, and I'm to the left of it, hit enter. Move your little blinky man to the right of it, hit enter, and press enter to get your solution. Now I want you guys to see something on this problem, and I'm going to write it on this little sticky note. I see the y5. That is clear to me. But what is not clear to me is x, it says, is a negative 2.017 e negative 6. Now you need to recognize e negative 6 as scientific notation. And what it does is it takes that decimal and it moves it 6 places to the left. 1, 2, 3, 4, 5, 6. If we move that decimal 6 places, that means there are 5 zeros in front of that number 2. Are you guys listening? If you have a number with 0.00000, it is safe to say that that is at 0. So we are at the 0, 5 on our graph. I just wanted to remind you about scientific notation. So the maximum is at 0, 5. Now let's finish. We have one more minimum, and I need to go and repeat our process for calculating the minimum by pressing second trace, the minimum. I am already to the left of it, hit enter, move to the right, hit enter, and hit enter to get your answer. So our other minimum is located at a 1.09, and the y is at 2.95. Okay. These are our minimum and maximums for this problem. Now, I sketched this on a sheet of paper for you guys to look at to try to help with doing the interval notation. When you do intervals, remember you're only reading the numbers off of the x-axis. You really don't include the y, so you're going to be using the 0 here, the negative 1.84, and the 1.09. Those are the numbers that are going to be in our increase and decrease intervals. Just those 3 like x values. Now, I tried to kind of blow the graph up for you guys, and notice I only put on an x-axis, and at this minimum I wrote the x that went with it, the 1.09. The maximum right here was at 0, so I'm kind of marking my x-axis. And this minimum was at the negative 1.84. So I've kind of done those tick marks, and we could also add on here a negative infinity on that end and a positive infinity as we keep going out this direction. Now, if we start looking at our graph and follow it, on this side of our graph, I'm decreasing, I'm falling, okay, and I fall until I get here. So this is a decrease, and on this part of our graph, well, it decreases on all of this side. So that would be from negative infinity to this negative 1.84. That is your first answer for decrease. It would be from the negative infinity, because it's this side of the graph, all the way to that minimum, which was at the negative 1.84. So I'm going to write that in, and that was a decrease. Okay. Now we'll move around on the rest of the graph. So looking at this piece, this is increasing. It's moving up, 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 up until it gets here. So it increased on this section of the graph from here to here, okay, which is from that negative 1.84 to 0. That section of the graph was increasing, okay. So I'm going to write that one in. That's negative 1.84 all the way to the 0. That was an increase. Now, move into our next one, and that was here. And if you look at my pen, we are going down, 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 down. We're decreasing. So it's decreasing from where? From 0 to 1.09. So, and that was a decrease. I'm making sure I'm putting it in the right category. From 0 to 1.09, it decreased. Okay. Now, we still have a little more section of our graph because we did this decrease, increase, decrease, and now we're here. What is our graph doing? From here, it's moving up. This is an increase, and it increases on this whole section over here because it continues to move up, up, up. So what would we write for that increase interval? Say it a little louder. Yes, 1.09 to infinity. And these are our answers for your problem number 2 on page 16. I'd like you to move over to page 18. And looking at your page 18, it talks about the zeros of a function. And the zeros are the points or point at which the function intersects the x-axis. I told you before when we were talking about this, they are the x-intercepts. Sometimes they call them roots. Sometimes they call them solutions. Excuse me. For the bullet number 2, a polynomial function of degree n can have at most n real zeros. So if it has a power of 5, a degree of 5, it could have 5 zeros. 5 different answers. A power of 3 could have 3 different answers. Then bullet number 3 says an even degree polynomial has an even number of zeros or no zeros. An odd degree polynomial has an odd number of zeros. And let's look at number 1. The first thing in problem number 1 that I'm going to ask you guys to do is factor it. Okay. So we are going to start out factoring out a GCF. What is our GCF in this problem? Yes, an x. Okay. So we're going to factor out an x. What's going to be left if I factor out an x? X squared plus x, and then you said what? Minus 2. Very good. But now we have a little trinomial inside here that can factor down. Notice my GCF I just brought down. Okay. And I want you to think about how this one would factor. You multiply to make the 2. What numbers multiply to make 2? Just 1 and 2. So the only way to multiply for a 2 is 1 times 2. We are subtracting to get a 1 in the middle. What needs to take the positive sign? The 2. And then the 1 will have to be minus for them to subtract to leave a 1 in the center. X squared will break down x times x. This is factored for this problem. Okay. Now, the next thing that I want you guys to look at is we would set them equal to 0 to find the zeros. We've done this before, but every letter, everything that has a letter gets equaled to 0. We did this in our quadratic unit and when we were factoring and solving. We equal to 0 and then we solve the linear, the little linear binomials. So this one I would add 1 over. When I add 1 over, I get x is 1. On this one, I would subtract a 2, and it's going to give me a negative 2. So we have our zeros, and even that first one, when you equal it to 0, it is 0. So these are the zeros for this particular problem. It wanted us to sketch the graph. So I know that it's going to go through the 0, the positive 1, and the negative 2. I know the ending behavior, it will have to be it's a positive odd, so it is a down and then up kind of graph. So this side, it's going to move downward. This side of it, it's going to move upward. I'm trying to sketch without really putting it in my calculator. It has to cross through these locations and then dip back down and cross through. I did not compute the max and the minimum. I'm just kind of giving you a sketch, okay? So my max and minimum on my little sketch are possibly incorrect, but the ending behavior and the fact that it crosses through those 3 locations, that part is perfect. We can go to our calculator and actually type it in so that you can see what the real graph looks like. So I went to y equals, and I'm going to type in the original equation that it gave us. And I'm going to press, that was not right. Sorry, guys. I did not get out of the exponent when I was typing. It's easy to make that mistake, and I saw it too late. Okay, once I have it in, I'm going to hit graph, and now you can see the graph, and it does look similar to what I did. Okay, theirs is a little prettier, obviously, and more precise, but it does cross through the -2, the 0, and the +1, just like I thought that it would. Okay. As we talk more, you'll see this even more in our other problems. Now, let's move on to problem number 2. And in problem number 2, I see a negative even graph. How does it end? A negative even. Both of them are moving down. It's a down, down. That is a negative even. So we know how it's going to end, but now we've got to figure out what the 0 is. Where is it crossing our x-axis? I don't like it having a negative in the front, so we could fix that by multiplying the whole problem by a negative, which makes them all switch signs. That is a quick way to fix that. Then I notice a power of 4 can nicely split into an x squared times an x squared. And a 4, we can break it down with a 1 times 4 or a 2 times 2. We are adding to make a 5. Well, it has to be the 1 and the 4 that add to make a 5. But the 5 is negative, so they both need to carry a minus sign. This is just practicing our factoring, but now I still see more factoring that can take place. I have a difference of squares, perfect squares. Remember that even though it's a 1, that 1 times 1 is a perfect square. Your x squared breaks into x times x. Because it's a minus, it has one of each, so there's a plus and a minus. Your difference of squares on the other one, well, the 4 is going to break into 2 times 2. Your x squared will break into x times x. One will be plus, one will be minus. If we equal each one of these to 0 to solve, this one's going to give me x negative 1. The next one, if I equal it to 0, I'd have to add over my 1, so I will get x as a positive 1 there. On the next one, if I equal it to 0 and subtract over my 2, I get x as a negative 2 for that one. And then the last one, if I equal it to 0, I'd have to add over the 2. And then I get x is a positive 2. Now, remember, these are our x-intercepts. So we have a positive and a negative 1. We have a positive and a negative 2. These are locations that it is going to cross through. the graph. We know the ending behavior is a down-down. If I just kind of draw a sketch without even my calculator, I know this side has got to go downward, and I know on this side it has to also go downward. In order to hit those others, it must come up and go back down and come and go back up and hit that one and come back down. Remember that it had a power of 4, so it could have 3 turns. This one should, I believe, have 3 turns. Now, this is not precise. I don't really know my max and my mins because I did not compute them, but I have an idea of what this graph looks like even before I use my calculator to find max and mins. I'm going to go put it in our calculator. Go to your y equals. Maybe I can type this one a little better. I'll try. Okay. Double check that you have every symbol, every letter, all your signs, and then when you're satisfied, press graph. Okay. Obviously, I didn't quite have my min and my max correct, but does it have that shape? It does. So I was off on my max and min because I did not really calculate those, but I did have a sketch of this graph. Okay. And part of my features are correct. It does end going down, down. It does cross through the -2 and -1, and it also crosses the 1 and the +2. So you can see that on the calculator as well as my little graph. Now, let's continue. And I want to give y'all just a moment to complete problem number 3. Okay. So I'm going to pause for a second, and I want you guys to try to factor problem 3. Okay, did you factor out the GCF? What is the GCF? An X. And what would be left if I take the X out? Okay, good. And then you can break that into 2 smaller pieces. So what multiplies for 15 but subtracts to give you a 2? Okay, a 3 and a 5 can multiply to make 15, and they can subtract to make a 2. We see x squared inside can break into x times x. What signs will we need to use? Which one gets the positive? Look at that a little closer, okay? We need the 2 to be left over a negative, so the bigger number should take the negative sign, okay? The 3 should take the positive sign, but when we do the zeros, when I equal x to 0, it will be 0. When I equal the x plus 3 to a 0, that will end up giving us a -3. When I equal the x minus 5 to 0, that one should give us a positive 5 answer. And these are the zeros of our factored problem. Are there any questions on this number 3? Okay. Then let's move on to page 19. And I want you guys to look at your problem number 4. Now, it talks about a multiplicity, and it says the multiplicity of a 0 is equal to the number of times its corresponding linear factor occurs. It's just how often it happens. It wants us to factor this first little problem and identify the zeros. So we can do this one together. My first step would be to factor out an x. When I factor out an x, that's our GCF in all 3 of these. You're going to get an x squared minus 6x plus 9. If you continue to break this down, 9 can break into a 3 times a 3, and they add to make a 6 if they are both negatives. Now, so our factored form could be written in x and then an x minus 3 squared, because there are 2 groups of x minus 3s. The zeros of it, when I equal x to 0, it would be 0. When I equal my x minus 3 to 0, I get a 3 that's going to add over, so it would be positive 3 and 0. My 0 has what they call the multiplicity of only happening once, because my 0 was an answer one time, but my 3 has a multiplicity of 2, because it actually happened 2 times. So its multiplicity was 2. Now, they want us to look at this problem in our graphing calculator. Now, we already know the endings of it, because yesterday we learned endings. It's positive and odd, so it's going to be a down-up. That's a positive odd graph. We also know it's going to cross the 0 and the positive 3. Okay, but they want us to think about the graph and see what happens in the graph. So I'm going to take this one and type it in our graphing calculator. Okay, once I am satisfied I did type it correctly, I'm going to press graph so you guys can see. Now it crosses through the 0. Okay, it crosses through the 0. It comes up and bounces off and then goes back up. It bounces off of the 3. I know my graph that I drew is not perfect, but at the 3 it bounces. It did not cross all the way through and go down below the x-axis. It only bounced off. But the 0, it crossed all the way through. So they conclude this with, if the multiplicity is odd, then the graph crosses at that 0. Our 0 had a multiplicity of 1, which is odd. So it crossed at the 0. It says if the multiplicity is even, then the graph bounces at that 0. So it bounced off of your 3 because it had an even number of multiplicity. Our 3 had a multiplicity of 2, which is even. So on even multiplicities, it bounces. Now, number 6, they did us a favor, and they already factored this problem. Okay, so you don't have to factor number 6. It is already factored, but they want us, bless you, they want us to find the zeros, the multiplicity, and does it cross or does it bounce? Okay, so looking at this problem, I see the 0 of this first group would be what number? What number do you guys think is the 0 there? Okay, a -7. What's the multiplicity? 2. What effect does that have then? It bounces because that is an even multiplicity. So this one is going to bounce off the x-axis at -7. Okay. This one, the 0 might be a little harder to find. So you may want to work this one out. Equal it to 0. You're going to have to subtract your 1 over. Then you'll divide by your 2. And so the answer to that would be a -1/2. So the 0 would be a -1/2 for that middle one. What is its multiplicity? How many times did it occur? Once. So that's an odd multiplicity, which means it's going to have what effect? It's going to cross through the -1/2. Okay. The last one, can you look at it until the 0? It's a +4. Very good. What is its multiplicity? A 3, which is an odd number. So what is it going to do? It's going to cross. Okay? So it's going to cross at the 4 on our graph. The only one of those that it would bounce off of would be our -7 on the x-axis. Number 7. It is the same type problem, only they didn't do you a favor. They didn't factor it. You guys are going to have to do the factoring. Okay? So if we factor this one, you have a GCF. Anybody recognize what the GCF would be? A -2x². I would pull the negative out. That way our leading number inside could be positive. When we look at what would be left over, if we pull out a -2x², then you're going to have x² left. If we pull a -x² out of a 4x³, it would end up being a -2x, because a -2 times -2 makes +4. What would it be right here that we would multiply to get a +16? A -8. Very good. Now, we can still factor this down a little bit more. 8 can break up into a 1 times 8 or a 2 times 4. I'm subtracting to get a -2. It must be which one? Okay, the 2 times the 4. Which sign is going to go with the 4? A negative. 2 will have to carry the positive or it won't subtract for the middle. Okay, x² is going to break into an x times an x, and now we can see our zeros. These two are easy to locate. The x plus 2, its 0 would be -2, and it's only happening once, which is odd. The x minus 4 would give us a 0 of +4. It's only happening once, which is also odd. Both of these odds are going to do crossing. They're going to cross at those x-intercepts. Ooh, okay. Now, this one in front, I left it for us doing it last. When we take a -2x² and we equal it to 0, and we divide by -2, a 0 divided by -2 is still 0, right? This represents 2 of your answers. So the answer is x equals 0, but it's happening twice. Now keep in mind we had 4 answers. This is all 4. You have 2 that are 0, 1 that's a 4, 1 that's a -2. Okay. That multiplicity is a even multiplicity. So on the 0, it is going to bounce. Okay. Your assignment is to complete pages 17, 20, and 21. I am letting the number 8 on page 19 You can read it, you can try it. It won't standard form. It gives you the zeros and the multiplicity. All you're doing is multiplying. First, outer, inner, last. You are multiplying. Okay? You can try that number 8. And your pages, once again, are 17, 20, and 21.